So in these problems, we've got another cubic, x cubed minus 6x plus 1, and we factorize, and we differentiate down to 3x squared minus 6 equals 0. Then we can solve for x now. We can do it this way. 3x squared would have to be equal to 2, and so x can be plus or minus root 2. So at positive root 2, we get y is equal to minus 4 and 2/3, or minus 4.66. Again, test it. Check before, so put in 1, put in 2, because root 2 is about 1.4, so we can check our values there. We see that we got a negative gradient followed by a positive gradient, which means it must be a minimum turning point at root 2 and minus 4.66. And when it's minus root 2, well, we get 6.66. So again, we test before. So test minus 2 and minus 1. We see our curve has got a positive gradient, then a negative gradient, which means it's a maximum turning point. So then there's our curve when we draw it up. So maximum turning point here, minimum turning point there. Question 9. When we get our function, derive it. We can. This line here we've divided and got everything by minus 2 to be able to factorize a little bit nicer. So we get two brackets there. The first one, 3x minus 2, comes down to giving us x is equal to 2/3. When we go through and solve it, our y value would be 9 and 8 on 27. Again, test before and after. With 2/3, we'll test at 0 and 1, put our values in, we get our values, our positive gradient, then a negative gradient, which gives us a maximum turning point. And then when x plus 3 is equal to 0, x would equal 3. Our y value of minus 40 when we test in the first derivative to give us a gradient, a negative gradient, 0, positive. So we've got to keep checking that first derivative, not just looking at the values, because we've got to test what type of turning point, what type of stationary point it is. So it's no good just to check the values and go, oh, that must be a maximum and minimum, because it might not be. So x squared outside of 8 minus x, expand it out to differentiate. Again, you could use the product rule, but it's a little bit harder. It's much easier to do it this way. Set it equal to 0. So x, that part there gives us x is equal to 0. And so it means it's going to be at the origin. And what type of stationary point do we have? We have one where the curve falls, stops, and then rises. So it must be a minimum turning point at the origin. And then 16 minus 3x is equal to 0. So we get 16 on 3. And not a very nice value, 75 and 23 on 27. And so we get tests at 5 and 6, because 16 on 3 is a little bit more than 5. And we get a positive gradient, 0, and then a negative gradient. So it's there, it's a maximum. So minimum at the origin, maximum at that value. So you can see that's the shape of our curve there. So keep remembering, how do we test for a stationary point? We test either side of it and see what the gradient's doing. So if it's negative, positive gradient, 0, negative, it's maximum. If it's negative, 0, positive, it's a minimum. Or we haven't seen them yet in the videos, but if it's the same on both sides, it's a horizontal point of inflection.